its potential would be important here. So for a beginner, it's going to require more, sessions. And we have those accessible to ourselves for, for free through the LinkedIn, which is the former lynda.com. When I teach LDS, I always, list those in the syllabi and the assignment sheets for reference to the skill sets we're learning. And, Rhino, the bigger thing I think here that is harder for a student coming into it, even if you go through, 4 years of undergrad in architecture or interior design, in the School of Building Arts, and you come out and you have some of these software experiences, and then you get in the profession, and things can really shift. You might, if you go into a firm and they're really Revit based, you're going to learn a lot more that you didn't know Revit could do by using that in a firm. And those, how many people are IPAL, who are doing the IPAL program, right? So if you're doing IPAL, you're already doing these internships, right? And then, depending upon who you intern with might determine, what software you interface with or what you do in that office and practice. So there's gonna be all, different skill sets and levels there. I think, for me, I've been running software. I mean, I first started using AutoCAD in the 80s. So I'm going to date myself here, but I think it's like AutoCAD release 8 or no 10. It was like a 1989 version, right? So way back when I was in high school, I got, we were doing mechanical drafting by hand, and then we had one computer in our drafting lab with AutoCAD on it, and we were so excited to take advantage of it. So for myself, having, stayed in the computer area and then also have done, handwork in architectural offices, and then kept up with all the computer software. For myself, I can see what the software's benefits are and what its negatives are, and why there's been a shift. Because I've been, not all people, my age or, in the profession understand that, because a lot of them, maybe never kept up with software and its evolution. So the big thing you got to remember here is AutoCAD, from when I first used it in high school, is still AutoCAD. There's been a lot of build-ons to it, but it's still AutoCAD. And one thing that software does not do, I say it's like a language. It's not like when we add new terms to the English language in the United States that we rebuild the whole platform of the language. Because software is written on language. It's computer programming, right? And that's called a language, like C++. It's, it's computer programming language. So one thing that AutoCAD is, it's still the same thing it was back in the 80s when it was first invented. So the language, they've never gone in and wiped it out and started fresh. And because otherwise it'd be like, taking English, wiping out English completely and starting all over. So software do not do that. So that's why Rhino is still Rhino. From, when I first saw it, I didn't really use it in grad school, and then I finally started using more when I started teaching here at SCAD. I put Rhino off. That was one software I introduced myself later. But once I got into it, I was like, wow, I wish I'd been using Rhino sooner, because I was using Autodesk products. And once I saw what Rhino could do, I was like, wow, this is a more robust software than AutoCAD. And I had, I had mastered AutoCAD using it in 3D, but I knew it had limitations. So there is no software that's an ideal platform that can do everything for you, right? Like looking at, software that can, do everything from, generating the architecture, doing construction documents, creating visualizations. We're mixing more than ever to do that. And then there's costs associated with these things. And when you get into the profession, the costs go way up. At school right now, you guys get access to all this software, and I say take advantage of it, download it, and then try to start learning some of it, because when you get out in the real world, they've set it up where licensures and all that are much harder to pirate. Back when we were in school, we were able to get copies of, stuff, and somebody would break the code and be like, we can get in here, and you can have this on your computer illegally. But today, I don't recommend that. But, we did it when we were students, just so we could have a copy. But now today, like, um, Autodesk was the first to do this. AutoCAD led it up. They said, hey, we're going to give the software out there to students, and it was at a minimal cost. Other software companies weren't doing that, and you'd have to, buy it, and most people were like pirating it. So now you guys have most of the Autodesk allow you all to access it for free. Rhino is at a minimal cost, after the trial's over, and I highly recommend that because they haven't been bought up. But one thing that's also happened is Autodesk has been buying everybody up. They're a huge company. It's like Coca-Cola and Disney. They're buying all these other companies up. And so Rhino's a holdout. It's McNeil is the one that owns that. So I always recommend supporting that smaller business model that they haven't sold out to Autodesk. Because I think once Autodesk takes it over, it's gonna be like every year you're gonna have a Rhino version, and it just doesn't make it necessarily better. So I got gripes with Autodesk being this big corporation it is. In the early days, it was like Rhino. It was just AutoCAD is all they had, and they became big because they made sure students could get to it easily, and then it became a big market, and so then everybody bought into the Autodesk product lineup. So you got that going on. And I'm speaking more from the United States. If we go to Europe, what's Autodesk's big architectural software right now that that would be the forefront of like when you practice architecture, which package do firms tend to use to design and do construction documents?
For us, Revit.
Yeah,
Revit.
for sure.
Revit. How old is Revit?
I have no idea.
9 years.
Maybe 15 or more.
It's going on 20 now.
Oh,
Revit
wow.
came out. Autodesk didn't own Revit when it came out. It was a small company, that wrote it. And again, you get a programmer like one of my good friends that I went to architecture school with, grad school. His wife's a computer programmer for NASA, and so she's behind the scenes writing the programming language. And then she has another guy she works with that does the interface, the icons, and all that. And he's the graphic person. So when Revit was written, I don't think that person, the people that teamed up and wrote the software, ever used Rhino. They're computer geeks and they're programmers. So they're not necessarily architects and people interfacing and trying to make that. So I find Revit way different than Rhino when it comes to geometry and how you make geometry in there. And so that becomes, I find Revit a harder tool set to learn because it's just, well, you got to click these couple buttons and it should just make that form, right? Like when you're in the masking tools. And where Rhino is very much built on geometry. And that's why I like it. So if you've had a geometry class, I always say go back to that because Rhino has everything you learned in geometry class, and now you can do it in the computer, and it's amazing. Because I grew up doing hand stuff, and when I first used AutoCAD, it was 2D. There was no 3D AutoCAD when we started using AutoCAD, and then 3D came along. It was a plugin, and it's actually the parent company now of ArchiCAD, who the plugin for, I'm pretty sure it was them that did the plugin for AutoCAD to be 3D, and then they started their own software, ArchiCAD. And at first, so they were doing the plugins. And so we began, I began when software was crude, just two-dimensional. Like, why would we use it? And then I had a professor in grad school that I TA'd for, he was using it at SOM in the 60s. He was using a form of microstation back then, and they had a supercomputer. SOM spent all this money, like if you ever watch Mad Men and that. So there's all these, make a long story short, there's all these legacies of the software, and there's pluses and minuses to each one. So I don't want you to think like, oh, you learn Rhino, it's going to be perfect, and then you go out there, and what you're going to see is you might work in a firm that doesn't even use Rhino, or there's one person in the office that's the Rhino user. And I've been at HOK's office in DC, and there was one gentleman that was running the Rhino for projects that needed some parametric skins because they didn't know how to do it in Revit. And you could do it in Revit. And when you look at the buildings that we're doing, they were kind of simple, but they thought they had to use Rhino to do it. And I was like, well, you could do it in Revit too. And then if you know Dynamo in Revit, you could start making it be able to be fabricated from the Revit file. So that's the big thing. I think, you might get in an office, and then if you're working, your project manager doesn't really understand software well enough, hasn't been around them, they could be aloof to the pluses and minuses of the software. So I think that's a good thing, because we can only do so much in a training session here, but I think if you guys see the bigger picture is just as important as hopping into software, learning how it all works, and then how does it apply. I'm gonna go ahead and share my screen. Let's do that. Now, I first want to show you guys before we get into Rhino. Can you guys all see my screen?
Yes.
Show you some tool sets or some sites. So the potential of Rhino, so kind of, again, like I said, Rhino is really good with geometry. And it's going to be, and then Rhino is really good about developable surfaces. Non-developable surfaces, Rhino is not the best software. If I'm going to be in the computer arts and I need to make a gorilla, I'm not going to use Rhino. And it's stupid to try to, so if you want to have your building look like a gorilla, I don't recommend you using Rhino, right? And, and first of all, why should a building look like a gorilla? And so if you're going to do sculptural things, Maya is the better software. And before Autodesk bought Maya, it was its own standalone software, and Maya was built to make characters. So it's more making characters, making hair, making a shirt do this in a movie, right? Move and flex. So Maya is really good at that. 3ds Max. How many people have heard of 3ds Max or Maya? Have you guys heard of Maya and 3ds Max? 3ds Max was probably what Doom could have been written in. I don't know if it was or not. The video game Doom, that was one of the first ones I remember in the 80s coming out, and 90s being a big video game. Well, that environment would be really easily done in 3ds Max. And why would they build, Doom, like a video game, in 3ds Max? Well, because it's really good with materials. I can map materials way more advanced than I can in Revit. Revit has limitations on material mapping. But then Revit has things that make 3ds Max just a visual mapping of materials, where it's I can't do thermodynamics properties with the materials in Max like I can in Revit, and I can't do structural properties with materials like I can in Revit. So Revit, outweighs Max there. So if I'm just looking at visuals, 3ds Max for video games is much better, because I'm not worried about whether or not it's structural. I'm worried about the environment. And then 3ds Max was one of the first software that had protection. So if you hit a wall, right, you don't go through it. You need that for video games. When did that come out in architecture? Not till Navisworks, that we can go through and find collision detections, in Revit in the building model. So, it came to architecture a lot later. So, we've had professors here in the past that would teach fundamental students Maya, and I feel like you're putting the cart before the horse. Why are we hopping into character animation software for architecture just because you want to be cutting edge and cool? So it's like putting the cart before the horse. So Rhino, to me, I love this software because it does go back to Euclidean geometry. And when you're in this tool set, this toolbar, they keep it kind of simple up here. It's old school, where you got the pop-down menus, which, Adobe still is like this, but all the Autodesk products, you click on something here, right, and it opens the ribbon changes. And here it's old school command prompt. AutoCAD used to be like this. So for me, going from AutoCAD to Rhino was quick. So if you know AutoCAD, the two of them are very familiar. Now, what AutoCAD has changed is the ribbon, and they're more like Revit now. So this ribbon thing's a newer thing, and then it makes how you interface a little bit different, right? So the thing you gotta remember here, Rhino starts from, basics like file stuff, editing, basic editing tools. And then when you get into curves, what I like about Rhino is it starts with the simplest geometry we have in a piece of software under the curve list. Once you get to curve, you're starting with geometry, and the simplest geometry for the computer to record. And it uses this later on too, why I stress this when I teach this. What's the thing at the top that you see there in that list? See the point, right? So point is the simplest piece of geometry we have in an environment like Rhino. What's the environment we're in here? Does anybody know what Rhino's environment is? Everybody's had ELDS 225, right? Electronic Design 1. Everybody's had that here at SCAD. So you all learned Revit, right? Revit doesn't put this environment in your face. But if I go over here to the perspective view, right, and we blow this up, what is this environment? Does anybody know?
Maybe 3D?
We're in a 3D, yeah, it's a 3D environment, but what's controlling the environment? How am I able to know where a point is in space?
Oh, the graph, like the X and Y and Z
X,
coordinate?
Y, and Z. Yeah, so if you do this with your left hand, if I get everybody to do this with their left hand, it's called the left hand rule, right? So if you right now you put your index finger straight up like, hey, I'm number 1. Thumb comes out like that to make an L. Now I'm a loser. And then you can do the middle finger this way, right? And then so what you get is when you look at it, your index is X, your middle finger is Y, and your thumb is Z. And that's the XYZ. That is a Cartesian coordinate system. Rene Descartes came up with that in the Renaissance. And that's how, if you go, this is where you got to go back to your geometry class, and you had to map Cartesian coordinate systems. The first AutoCAD that was out there, the early versions of AutoCAD, I had to type in, if I wanted to draw a line, I had to type in Cartesian coordinate systems. I had to type like, you would say you wanted to do 0, so the Y or the X is 0. So if I wanted to have a point up on the Y axis, I do 0, 5. And then it was 2D, so there was no Z. Z came later into software. So I could do 0, 5, and then if I want to make that 10 units long in the X, I would do then 10, 5. 0, 5, 10, 5. And that would give me a line 10 units long up in the Y, right? A horizontal line. Does that make sense? And I can still do that today in here. So if I go in here, right? This is, I'm just, you know, I know we can jump more advanced, but I think for the people who are intermediate, if you were never taught this, then you know how this system works. If I start this polyline, 0, 5, enter. Oh, let me get in here. See, now what I say, 5, 10, watch where it ends up. Oh, make sure I'm keyboard. It didn't end up where I thought it was going to. All right, we gotta do Z. Sorry, I gotta do Z in here. Now I'm messing up because I never entered this way. 0, 5, 0, yep. 5, 10, 0. Why is it in top view? If we go there, it should. Why am I messing up? Oh, the Y is, I'm messing up the Y, right? So you guys knew. All right, so if we do 0, 5, gosh, Cartesian coordinate systems, I'm messing them up. So then I need, if I want to go in the X, I want to go 10, 5, 0. There we go. That's what I wanted. See that? So it's 0, 5, and then 10 for the X is, notice it's 10 units across. See that? Look at the grid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, if you count those. You guys see that? So then 10 is the X. Over here, the X is 0, and then the Y is 5, and then the Y is 5 here. It's a Cartesian coordinate system. And if I hit enter, right, there's my line based off those Cartesian coordinates. So CAD packages, AutoCAD, Rhino, the XYZ and the Cartesian coordinate systems in your face because they were built on that. And in the early days, that's how you had to enter lines. And that's why it's still there. Because again, it's a language, right? You can't get rid of your alphabet. The alphabet here is the Cartesian coordinate system. Is everybody with me? So real quick, watch how fast will the software find midpoint? Look at that, found midpoint like that. What's the coordinate? What's the midpoint coordinate I just snapped to? You guys see my screen? it's going to be, right, if this is 10 over here in the x, so that's going to be halfway between that. So we add, right? This is going to be 5, 5, 0 is the midpoint. And how quick, and then how accurate is the software on this?
It's 100% accurate, right?
Yeah.
As long
Because
as
it's math.
midpoint's on.
Yeah. So what goes on here, to find midpoint, how does the computer find midpoint? I know I might be boring you guys right now, but I find this so important because I'm going to show you some work that Mateo Fernandez, who is a recent grad who he was working for, and he was working for Mark Forns. And if you want to be able to do this stuff with, and this is using Rhino, you got to know this stuff because it comes down to respecting geometry. If you don't, you're not going to build crap in the world that is buildable, right? And the stuff they do is amazing. You're going to look at it, and it's done in Rhino, and it's done using Grasshopper and scripting. So if you don't understand the basics, that it's a geometry platform, math. So you got two big camps. You got math and geometry. And here, when I click on the line tool, I'm using a geometry thing, but behind this system is math. The computer is all mathematical. So right now, to find midpoint on that line, what the computer does is we have, if for the x, it's going to take x1, right, plus x2, and divide by 2. And that's going to equal xn for midpoint, right? So you're going to take x1 on the line, which would be one endpoint of the x, and x2, the other endpoint of the line, divide it by 2, and you get the midpoint. Does that make sense, everybody? So you get xm. And then y is the same way. So if I do caps here, y1 plus y2 divided by 2 would equal ym. And the computer is doing that. And it does it how fast? In a split of a second. So the computer is recording everything. Like when you draw a line, it knows every point in that spatial relationship of that line in the XYZ coordinate system. And so that's why we use computers, is because they're recording things. Our brain can't work that fast. Like for me to, if I gave you a random line like this, if I do a random, let me get back here. If I do a random line in here like this, and I say, oh, I'm back. And then I go find the midpoint. Look, it found the midpoint instantly. And it knows exactly where that is in the Cartesian coordinate system. It's going to know the X, Y, Z coordinates like that, and it finds it like that. My brain can't, like right now, those are random points I just did because I randomly selected. My brain can't think that fast. That's why we use a computer. Because it's calculating things, the CPU is calculating things so much faster than what our brains can do. Like I would have to do this formula here to technically figure out that midpoint. So I'm in the 80s, I'm hand drafting this stuff. We used to hand draft. For me to know the midpoint of that line to give it to a contractor, I got to do the calculation. And let's say that line's three-dimensionally in space, floating in space. And I need to find the midpoint because we got to put a beam there. I got to connect a beam to that midpoint. I got to be able to calculate that. Back in the day, we had to do that by hand. Does that make sense? So, and then I would have to do descriptive geometry if it was a random beam in space, not in any planar situation that's an easy plane to define. And then you had to know how to do descriptive geometry. So when AutoCAD came along and started doing 3D AutoCAD, I was like, whoa. I was like, I want to use this because now I don't have to, I'm going to be able to go to that midpoint and define it and put a dimension on that. So I can come in here and and dimension this quickly, right? And it's going to give me exactly where it is in space. Because and for me, it was like a no-brainer to go over to computers. But the thing I remember is like you guys, what I hate about schooling, how many geometry classes did you guys have? One?
In high school, just one.
Yeah. And what did you get to? Where did it end? Did you do any parabolic stuff?
I did, but I was in an accelerated math program, so we went quite in depth. But
Yeah.
I'm
So
not
like,
sure how standard that is.
how about others? Did everybody have at least
Same, but
one?
it only gets covered by like one unit.
So not very much that you did.
No.
No. So this is what, let me show you this. This is what Mateo was doing for Mark Florence. Let me clear my drawings here. This is Mark stuff. Now I know this looks, super, people call it organic, but this is very controlled geometry. Like Mateo, his boss would, Mark would yell at him all the time. He wasn't a real nice guy to work for. There's Rhino. Anyway, I won't go too far, but this is all done in Rhino, Rhino and Grasshopper. And it's all laser cut. So if it's laser cut, it's flat. You're cutting flat material to make this three-dimensional looking object, right? That's very, curvilinear. So you have to be very clean. And so what Mateo said he learned after working for Mark, he came to me, he WhatsApped me, he said, he's like, I don't think I can work here anymore. And I said, Mateo, you learned what you needed to learn. And you learned how to do super advanced stuff in Rhino and get and understand what developable surfaces are versus non-developable. I teach a fabrication methods course, and in a quarter, it's hard for me to get students to see that, to see, because you guys will go in, you'll start using Rhino, and you immediately make, I can make this curved thing, but it's out of control, and that's because you don't like. And Mark is in here, and he's running this office, and he's constantly like, slapping you. He's like, hey, you can't do that. That's not going to work, right? And then what's cool about this is he doesn't do structural engineering on this. He just figures it out, kind of like he's done enough of these designs that, they the structure works. So there are sculptural outdoor pavilions that he's doing for different projects. But that's the potential where you can go. And again, in school, I think it's kind of hard for me to fully get students to, to see the control that you have to have of the geometry, and that just you can't just draw a random curve and expect it to work and be buildable, be developable, right? So things I would say you should start looking up is like a surface that's developable versus a surface that isn't developable. And you guys all know what they are, right? So a developable surface, right? If I do something like a cylinder, right? And this paper is really thick. A cylinder can unroll and lay down flat. So that's developable. And remember, this form you're looking at right here is made from flat material. So all those forms have to be developable. It has to be something that can come, from a flat stock material off of a laser cutter to drill the holes out and then be able to fasten it together and then go into developable form. So you can't do this. You can't be that. You can't be a wadded up mess that Frank Gehry loves to do, right? So Mark is, so I wish everybody could, have to learn how to do this in school, because then you would just be super advanced when it comes to geometry, respecting geometry. And then you see Frank Gehry, not all Frank Gehry's projects are like this, but a lot of times this is what he gives to you guys. If I was Frank Gehry right now, I said, here guys, I want this to be the building, right? And then you got to figure out how to freaking build the thing, and then it's a freaking mess. And where Mark, he works off a different platform. He's like, let's come at this from a developable way versus, try and take something undevelopable and make it developable. Does that kind of make sense? So right now, like these surfaces, once I crumple it, I can't get it back. You know what I mean? Yeah, I can do that, but look, it's all wrinkled. That's a non-developable object. So things like cylinders, cones. A cone is developable. You can unroll a cone, it lays flat. Yeah, it's usually a sketch or a wadded up piece of paper by Gehry. And then we had John come in. spring quarter. He's working for Frank Gehry, right? And he was showing me a house that he's working on in San Francisco, and it's just a freaking mess. It's a collage of different forms coming together, and then somebody's got to figure out how to make it developable, usually the builder. Because we got to be able to build the things in the end. So the problem with the computer is Rhino is going to let me do non-developable surfaces right off the bat. Like I can start stretching and pulling these surfaces, and then it automatically becomes non-developable. So that's where you have to be in control of it. So I'm just trying to stress that. And so we go back here to curves, right? This is like a department store, my beginners, right? So we got points is the simplest object. Points become very powerful later on when I want to do things more complex. I go back to point clouds to be able to develop a surface with panels. So I could show you that today. Like how much time do we have? I need to get into the software, maybe half hour.
Yeah, I say people can leave at a half hour if they want to, but if you want to stay on and do more, I would be interested in learning a little bit more.
Yeah,
Okay.
loving to learn.
All right, so in here real quick, when you guys start to learn this, and you'll get this in the the LinkedIn Learns, you go from a simple geometry, lines, polylines become more complex rectangles, right? And then you get down to, parabolas, hyperbolas, a catenary curve, and then even helix and spirals, right? So this is the most advanced. Then halfway down, then these are all going to be editing tools for curves. So this last half's going to be a lot of editing tools. So at first it's like, what the heck is this? When I teach a course, you got to do the epistemic curiosity where you're learning tools to get a task done, but then hopefully your diversive curiosity gets you in here and you just start trying some things, right? Once you get the basics down. And then the next thing is surfaces. Surfaces, the way to think of them is if I take two lines, right, in space and, like this, two lines in space, and I can loft those together, right? I go up here to surface and loft, and I get a surface between those. Let me turn on my shade mode here so you can see them. And then that's a surface generated between them. So it's like a thin sheet of paper is the way you want to think of surfaces. But in the computer, what's interesting about surfaces, they have no thickness. Though they can I can map a material to a surface, but technically they have zero thickness. So they're planar objects, but the plane can warp in space, and so they can end up being non-coplanar. So right now, this is coplanar, this object I just made, because if I go to perspective, it's flat. It's all on one plane. See that? Even though when you look at it, it might not look like that. So now if I map points into this, if I add a point grid to this, oh, I didn't download tool sets. Sorry, it's my SCAD computer. I'm not going to be able to do yeah, I don't have the tool sets in here. Dang it. But if we wanted to do another workshop, we could and do a more, get into some more advanced. But I can map points into this, and then they're all going to be coplanar. Does that make sense? And if we go over here, Rhino is going to allow you to edit curve points on these objects. So if you started warping this thing, then this thing would become non-coplanar, right? So if we get the control points on this surface, right, and I choose that point there and I grab it like that and I start to stretch it in space, and then I stretch it back that way, now this thing is no longer flat. And just by doing that, this is where like people like Rhino, oh, look, I can curve. Now I get this really maybe dynamic curved wall. But right now, just by randomly doing that, this thing's probably no longer developable, right? And then Rhino, what can do to let you know if it's developable or not, you can like lay it down flat. Like you can unroll this. I can do an unroll surf here. And then you select your surface unroll. And see, it's got deviations in it, so this thing more than likely is no longer, so like by unrolling that right now, if it's developable, I could print this on my printer at home on a sheet of paper, take a pair of scissors, cut it out, and I should be able to roll it into that surface. if it's developable. So you can make a physical model from your digital model. But if it's non-developable, right, because I go in here and I start pushing and pulling these points everywhere in space like that, that's going to make it non-developable. So that if you unroll it and try to print it, so that's where you need to know the difference between developable and non-developable. What's a sphere? Developable or non-developable? Think of a soccer ball.
I mean, if you 3D print it, it's technically developable.
But if we look at surfaces being developable,
Then it's
right?
non-developable.
Yeah. So like a soccer ball is made of, like hexagons, octagons, because you can't just take a single piece of leather, cut it, and make it spherical, right? So spheres are non-developable. So the way you got to think of this is buildings are made of skins. You can't just come in and make a 100-foot long wall, by 200 feet high, just one material. It's going to be made of panels. So if depending upon the surface here, whether it's developable or non-developable, is going to determine how we make it. So if this is non-developable, and let's say this thing's like 100 feet long and 50 feet high, and this is the wall you want to do for your architecture, every panel in here is going to be a custom panel, and your cost just went up tenfold. And Mark Forns doesn't do that because he's making sure he can develop his panels from a laser cutter, and he can get forms that are dynamic, and they can all be cut from, you could make a Mark Forns sculpture by printing it on, your printer, on a material and cutting out with scissors and kind of, if the paper was rigid enough, and build one of those things. Does that kind of make sense theoretically what's going on here? All right. Anyway, so I don't know, what should we do? Should we do some, I think the theory behind it's maybe more important in a short little lesson, but what would be your preference to end here? I mean, we got beginners to intermediates, so I mean, I could, go over the important basic tools in here real fast, what you need to be paying attention to when you're working in Rhino. I could do that real quick, and then we could look at maybe a few tools, and I'll make something real quick here before we end. Okay.
I think it's a good idea. Yeah.
Okay. All right. So over here on the left are going to be like your icons for tools, right? And then if you see the little down arrow, there will be more tools in here. Just remember, all this stuff here is also here. So if I go to ellipse, right, those are all there, and then it might be over here in an icon. So with Rhino, you have it in the menu. The menu is going to have everything. The icon might not. Okay. So, if you're not sure where something is, maybe go here. And then I tend to work with curves and surfaces and solids sometimes. And then meshes, when you get into more advanced things, meshes become important, especially in non-developable objects. Meshes can be a little bit a better tool to work with. But a lot of times teaching beginners, I say, don't worry about meshes right now. That's, when you get more intermediate advanced, we'll do meshes. I say that. And then you got your dimension tools and stuff like that, transform. But another big area, so transform is going to apply to anything, right? I could possibly scale anything. So these are going to be more universal transforms. And if I go back into surface here, remember I said at the top's the simplest surface, just like in the curves. Halfway down, you can make a surface from a heightened image. You can do a height field from an image to make surfaces. And then once you get below halfway here, these are editing tools, modifying tools to surfaces. Same with solids. Halfway down, you get to a torus. And then after that, it's editing tools for editing the solid, okay? So the library, the breakdown in each one of these menus works the same. And then the other big thing you got to do down here, you got to control, your snaps. These are object snaps. So, and once you set them up, they'll be on. So end, midpoint's important. Usually they'll have like intersect, and you need to get these turned on. So you have your object snaps on. Near snap I only use when I need it. And near snaps can be when I got maybe like a spline here in space, and I just want to kind of randomly pick to start snapping to it. See, and then near snap lets me snap anywhere along that line to start generating a geometry off of that. So you got to use your object snaps. But I turn near off when I'm not using it, because the problem is if I get like a line and I just want to get to the midpoint, near snap gets in the way. See that? Because now it could snap anywhere along there, and I just want midpoint. Midpoint will override it, but usually I leave near off, so I just mess up and turn it on only when I need it. So near's just, it's basically grabbing hold of the line anywhere along it. And then down here at the bottom, you have, if you want grid snap-on, ortho lock. Shift is also ortho lock, so learn shortcuts. It's really critical. So I never use ortho lock. I usually use the shift key when I want to draw a line straight. So if I come in here and I want the line to go just in the X direction like I am, I'm holding down the shift key. And if I want to go in the Y, and then I'm drawing everything orthogonally here right now. And then the other thing, so OSNAP is on here, right? So you turn it off, that disables it. Object snap. Smart track, I like that. Smart track does this when I go here to the midpoint of the line. And if I want to reference maybe like the midpoint of that, look at that. So I can hover over the midpoint up here, and then I know I'm going to get a line that is orthogonal there because smart track is on. So that line went to the midpoint of this one right here. See that? And that's smart track doing that. So that's an important little tool because you can hover over something and say come back this way, and it's going to track that midpoint back down to make this horizontal where you end it at the midpoint of that. So smart track makes sense. Is that a good way to explain that? So that's an important one. Then the gumball, this one I love. I wish Revit would have the gumball. This is one of my most favorite tools in any software. It's this thing here. See that? When I have something highlighted with the gumball on, with it off, it looks like this. You just see the lines highlighted. And then with the gumball on, it gives you this. And those that are intermediates, they know the power of the gumball. So right now I can Control C, Control V, that object that I have highlighted, and then come to the gumball to drag the copy away. And if I hold down the left mouse button on the red axis, the X axis, it just moves it directly in the X. And it's moving it randomly right now. And if I come to the Y axis, it's moving in the Y. And if I want to move it up in space, I grab the blue axis, it's in space. The other cool thing that those that are intermediate, they know this. I can left click once on the red axis and say, hey, I want that line to move 10 feet to the right. And I just type, or I'll do 1 foot. So it doesn't go off the screen. Type 1 enter, and it moves it 1 foot to the right. If I want to go 1 foot in the Y, click once, hit 1 enter, moves it directly. And then if you want to make copies, it's like you do in Word, Control C, Control V, I got a copy, and then I want that copy to be 10 feet in the negative in the Y, I do -10, there's a copy of it 10 feet back in the Y. And then the gumball, these other lines in the gumball, so learn this tool, like I'm not gonna go all the way through all the tools here in the gumball, but you also have rotates. And you gotta go back to the left-hand rule for the rotate. This, we're in perspective here, but if you look at that, these are 3D rotates. If I do the blue is just going to rotate in the top plane, right here in the top plane. So if I grab the blue and just hold down with the left mouse button, it's rotating in the top plane, right? Or Control Z. And then if I rotate here, the red's going to rotate in the YZ plane, right? So that one rotates in the YZ plane, the object, see that? And then if I want to go in the green's going to rotate in the XY plane. I'm sorry, in the XZ plane. So it's a 3D rotate. And then again, just like moving, if I left click once on here and say I want that to be at 45 degrees, I just left click on the blue to rotate it 45 degrees in the top plane, enter, and it's rotated. Right, in Revit, that's a pain in the butt. Right, in Revit, I got to go find the tool, I got to go find the rotate tool, and if the plane isn't set up, right, you got to make it's not going to rotate in a different plane unless you set up that plane. So like the gumball tool, if again, and Revit's built on this other language, and AutoCAD could do this. AutoCAD could add the gumball. Revit, they probably could, but they demand too much of planes being set up prior to be able to break a plane. Like you're locked into planes that the geometry is built in, and to get that geometry out of that plane, you can't do it. So again, it all comes back to, understanding geometry terms, why, and if you guys knew geometry better, I think, you could evaluate these software better, like how they start to work from a geometry standpoint. Anyway, try to pay attention to that in the future as you work with the tools, how it works geometrically. So anyway, so questions on the gumball? There is a trick if you don't want this in the center. It does go to the radius, the center point of the object. So if this was finished out as a rectangle, it's going to the center point. You can move that around so it's not on the center point for the rotation. If I wanted to rotate it here at the corner, right? You can, what is it? No, I'm going to forget. This is the one I always forget. It's this one, right? Relocate gumball. And then I can click there to place it there. And then, well, yeah, I can actually change its coordinates like that. That's one way to do it. Now it's rotating from that center point there. So anyway, once been learn the gumball. It's an important tool. And then learn how to, move it to be where you want it to be on the object, okay? So it's this little white button here. It gives you options for the gumball. So that, okay, the white circle versus the dot. All right. So once you have things, let's look at the power here of Rhino. So I got this non-developable surface, and I can show you how it allows you to generate stuff quickly, and then, I'll do it to make this undeveloped. Now, the thing I recommend for this is layers, just like AutoCAD. SketchUp has, how many people are AutoCAD users? A couple. So set up layers, right? Right now, I'm not paying attention to layers. I'm going to go over here to generate some geometry with some different layers here. So I'm going to make layer 1 current. And there's some tools like, let's say, what I recommend in Rhino is you got to build profiles, just like you would in Revit, to make a 3D object in masking tools. Like maybe the closest thing in Revit's masking tools to this, right? How many of you use the masking tools? Like in conceptual masking? I like going in conceptual masking, right? So this is where Rhino would be similar to that. So you do need some profiles, right? You got to start with some 2D geometry that you're trying to make a 3D object out of. And then like I did to this thing, I started warping it by getting these control points on, right? So I went over here, and you need to learn how to turn control points on. So once you have a control point on, now you can manipulate this surface, and now you can start push-pulling it. But like I said, when you do that, even like with a Revit mask, you start pulling the vertexes, it can become non-developable very quickly, and then your cost of your architecture. And so right now, what I want to do here is let's do a tool like contour. And so the way what I try to do in Rhino is build things out of surfaces and then come back to the structure. So we did this spring quarter. I had Jesse and Chandler, they all did, and Solange, they all did folded paper exercises, and we folded paper. And then we added spaghetti or structure to the paper after we had folded the paper. So Rhino works kind of the same way, like those paper exercises we did is the way I would think of it. So if I wanted to get like ribs in here, and let's say this would be a pavilion with some structural ribbing, the contour tool I'll use to help do this. And then up here in the command, you got to read the command prompt. It says select objects for contours. I'm going to select the surface, and I'm on layer 1. I want to be on a different layer to do this. So I can turn things on and off. And then I'm going to hit enter, which is the right mouse click, and it says select contour base plane. I'm going to start over here, and I'm just going to draw a line in the X and go this way. And so I drew a horizontal line. So the contours are going to be made perpendicular to that line I drew. So if I was in, maybe if I get out of this perspective, you guys can see this a little bit better when I do this. Let me get my shade mode on. So yeah, you gotta learn how to do shade modes and all that. So you can see this is really a warped surface, right? But this is, I'll show you how advanced Rhino can be. Let's delete some of this other geometry that's in here. All right, so we just have our one surface here. So if we do contour, what this is going to give us is lines on that surface. And this is where this software is. I wish Revit could do this. Revit doesn't do it. You can do this, but it's so hard to get Revit to do this. So I'm going to select the surface and then contour base. I'm going to go back here to the bottom point, and then I'm going to go straight in the X like that. So I'm just drawing a straight line in the X. And then it says, what's the distance between? I don't know how big this object is. Let's do every 2 feet. And then it does contours on that object every 2 feet. Does that make sense? Let me make a copy of this, and I'll show you what it does if we draw the contour line in a different way. So if we go back here and I go back to the contour tool, and sometimes I'll type if you remember the tool. You can just start typing instead of trying to find it where it is, because it can take forever to find it. So I find it better in Rhino to remember the name of a tool, write it down in your notes, and then you can just type it in. You can just start typing from anywhere. So I would do it again. And then this time, let's watch this. I'll do the contour line this way. See this? I'm drawing it. The lines of the contours are going to be perpendicular to that. See that? So now I got, different patterns on here based on how I drew the contour line. So this one's a little different than that one. See the difference there? So the contours are made perpendicular to the line you draw, and then you can define the space. Now, what can I do with that? Real quick, we can go up here, we'll do something super fast, solid pipes. And I can add like a structure to it. So before I do this though, I'm gonna go to a different layer to put my pipes on a different layer. And then it says select rail. So I can select all these rail, multiples here. There we go. And then I can select all those curves and rails. And then once a pipe radius, I'm gonna do like maybe 0.25 for the radius. And now I got this thing as a solid. So now if I turn off the other layers, there I have something ribbed that fast, right? So that's me. Again, you gotta start with the curve tools, and then I try to get a surface, and then I use the surface like I would a paper model to generate structure. And to do the structure, I went into the solid tools and did a solid. Now I could do there are surface tools in here. I could do sweeps. Sweeps would do something like the pipes. Pipes is just a quick way. The thing with pipes I don't like is you're only going to get tubes, right? The only option there is tubes. If I wanted to make these rectangles, let me go back to the other one. I'll make this one rectangles. I could do that, but it takes a little bit more time. So if I went back to my top view and made a rectangle here, profile, snaps, maybe I need points. It's not going to find that. There it is. We'll find it here. So we'll make a rectangle off of it. I could extrude that along that path if I wanted it to be like a rectilinear object. And then for that, I could do, you got to try some different ones. We could try sweep one rail here, select rail. Rail is going to be the contour line. And then you got to constantly read the command prompt in Rhino. And it says select cross section curves. I could select, then that's going to be my cross section. Then I'm going to hit enter. And then this I'm going to move here to be aligned. You just grab it and then I can align it. That looks good. And then it's going to do this rectangular sweep along there. And then you can play around with these tools, to see what they do. It'll give you like visuals in that. And then instead of pipes, right? So structure, again, the contours are just 2D lines. So that's just a 2D line built into the surface that then allows me to sweep a geometry into it, right? And a sweep is basically, I can set a profile up to go along that. In Revit, in the massing tools in Revit, I can do the same thing. I can draw a line, I can draw a profile, but in Revit, I have to have this object right here. You guys know Revit massing? Let me show you this real quick. so you can compare and contrast the two. Like in Revit to do the contours, that right now I wouldn't. I would have to think about it. The contours are going to be much harder. But if I wanted to do the sweep, I can show you that. Shoot. Why is Revit 20? That's where Revit drives me crazy anymore. I don't know where to go to find the masking tool. Why doesn't it just go there? Has anybody used 21 yet? English, US, I guess.
I still had 2020, I think, when we were in our studio.
Yeah, God, this is
Whoa.
where Revit, this is where Autodesk drives me crazy. Like, it should go straight to the massing. I should be able to start a conceptual mass. Now I gotta go dig for this in the library. This is
Yeah, it was never that
this is-
complex.
Yeah,
This
this
makes me
is
not want to download 21.
this is why I don't like Autodesk anymore, because then this crap goes on. Like 2 years ago, you would just go straight to the massing. Now I gotta go find it. I have no clue where it is. Yeah, this is my SCAD laptop, and I haven't had a chance to play with 2021 because I just got it the other day. You're kidding me. This is BS. Sorry. But I mean, I love Revit to death. I love it, but this is the stuff that's driving me crazy with it. And then you guys being beginners, here I am, I'm advanced in it, and I'm going to struggle to figure out where the heck the freaking libraries are. Sorry, I thought this was going to be a quick little thing. It might not be now. No, this is.
Revit's kind of like a test now of how badly do you want to make something.
I just can't believe they're doing this, that they allow this to happen. I mean, this is.
I think
Oh,
that
here it is. Here's the Imperial. I got it. Imperial Library. Mass. All right. Yeah, but that's not where the RFP is going to be. It's the library. Anyway, yeah, my unbelievable Revit. What I was going to show you is how you do a sweep in there. I would draw a line, but with Revit, I have to lock a work plane into that endpoint, and you set that up, and then I can project along it. So Revit is not going to generate that. Like in Rhino, I don't have to make that profile I draw here at the bottom. Like this profile, I'm just drawing in the top plane because I'm bound to the drawing plane. In Revit right now, this wouldn't work. If I did the same thing in Revit, it's not going to sweep this rectangle along that line. What I'd have to do is click on the little node here in Revit, set that as my work plane, then draw the rectangle into that node. And then, so it's probably going to be like if that line's coming down in space at a weird angle, then the rectangle might be like, if I use my phone, the rectangle might be built like that. And it's not, flat, horizontal in the X, Y top plane. It would have to be built like that to sweep. So Revit's more picky on sweeps, where Rhino will let you sweep anything. It'll let you get away with non-developable surfaces really quickly.
We can
And that's
also
why,
cover that.
that's why, go ahead.
I was going to say, we can also, if anyone's interested in seeing that, we can have Professor Rhino show us in the next workshop too.
Yeah. And if you guys, again, I know this is just an intro to like show you the power of Rhino, but I definitely recommend for me, I knew AutoCAD really well. I was an advanced user there in 3D geometry. I spent 2 weekends doing the LinkedIn, back then it was lynda.com on Rhino, and I learned Rhino. So you can give yourself like commit to 2 weekends. And I recommend doing it for studios. Those that had deets, right? You had to do that, right? You just went out there. The thing is, you might not have a Professor Dietz there showing you the software and the tools aligned to how he wants you to use them in the studio project. But I'd recommend doing like LinkedIn's and just say this weekend I'm going to commit 4 hours today. And then those that haven't used Rhino since ELDS 225, do you remember anything really? You forget, right? So the big thing here is maybe say 15 minutes a day. Just make that commitment. Say, I'm going to do 15 minutes. I'm going to open up Rhino and just play around in it and draw. I just want to try to draw some lines because you got to remember how the mouse click. I'm always messing up. I go Rhino, I'm like, the right click, and then I'm doing Revit stuff, and I'm messing up, and it's I always get discoordinated for a second because it's a different instrument, right? And it takes a second to just get used to the mouse. Just go into Rhino, and if you can do anything, this when I was learning guitar, the guy, I love that he said that. It's like, just pick up the guitar, play for 5 minutes. But what ends up happening is you end up spending maybe 30 minutes in there, right? And you spend a little longer and you're like, wow, I like what's going on here. And that's when you'll get the learning curve going, right? So if you do anything with Rhino, say I'm going to do like 15 minutes a day in here, just doodle like you're in your sketchbook, just doodling, sketching. I mean, and then there might be times if you want to get more serious, I realized when I was like learning guitar, I would do this. I would get to the point playing something, then I do it again, sounds the same. I do it the next day, sounds the same. The next day, sounds the same. So I've plateaued, right? I'm not doing anything different. And then when you notice that in the software that you're not doing anything different, you've leveled out and you're not learning. So what do you need to do? Go to LinkedIn and say, all right, let's learn some advanced tools in LinkedIn. I don't know yet. Push your brain a little bit there and say, oh, now, and then once you get those down on LinkedIn, then to not lose them, spend 15 minutes a day practicing those tools. And when you plateau again, move to the next set of tools, right? And so it doesn't have to be, I know for me, I had to learn it because I had to teach it. So I was like, I got to do 4-hour days, over the weekend. Some people don't mind doing that, right? Where you'll commit 8 hours this weekend learning a new software. Right now, in my studio, right, we're doing Adobe Illustrator, some of them for the first time. They need to commit 4 hours in there, maybe 8 hours total over the weekend if they want to, really start applying it to the studio. So I'm forcing them to learn some new software, to apply it to the project. So when you got that, do it because, again, that's the way I always learned it when I was young, and I came out and firms were wanting to hire me because of those skill sets, right? Knowing those tools. We're the youth, you guys are the youth. You should be coming out. The old people, there's not as many people my age that own firms that really understand the software. There's a few out there, but most become the business owner and they're running the business side and doing the client meetings, and they're no longer on the computer, making the designs. You guys got to do that. So they want to hire you guys because of your skill sets on the computer. So you need to come out and then there's going to be people in the office that are doing the the designs and the documentation. They're going to be more advanced to you, and that make that a buddy because you're going to learn from them and up another level. Right? And you're going to have to apply it in an office, right? You have to use those tools. But in school, each studio is different. Some professors will teach you software, some don't. I know he'll teach software. Dietz will teach software in studio. I'll teach software in studio, but not all, but we're ELDS faculty, right? So anyway, so again, if you can just do 15 minutes a day, or if you're going to apply it to your studio project, then you got to spend the 4 hours a day, for a couple of days, right?
Right. I'll even add to that too. I mean, you can do one, like, I think building towards something is a really great way to practice, because I don't know if it's on LinkedIn Learning, if it was just on linkedin.com, but one I did was just building parts of a spaceship. And I think learning how to apply building shapes practically and in a fun way, because you're building a freaking spaceship. It's, if you're doing something that's fun while you're learning, it's also easy to get lost in 4 hours. So yeah. I definitely agree with that.
I think also things like what Professor Bacha has covered today are also extremely important. Like, you can go in and you can learn how to use these tools, but if you don't understand the actual basis behind the creation of each tool, it'll make doing any type of advanced work impossible. So you have to understand why the tools have limitations and the purpose of each of them, as well as the math behind it.
Yeah. Yeah, and I mean, these things are really advanced. Like Revit can do amazing stuff. Rhino, like in the Mark IV and stuff, it allows you to build things from it very easily because I can unroll it. There's no unroll tool in Revit, in basic Revit. Oh, one last thing I didn't end with. All this stuff we're doing in Rhino is not parametric, right? If I come and change this surface that this thing's built into, this thing, right? Let me show you one last thing, because this is where it's different than Revit. And this is why you gotta learn Grasshopper. If I come in and change the surface shape, right? One last thing we'll end here. Notice that this thing, this poly surface I made, doesn't bend with it. See that? Can you guys see that? In Revit, if I go in and change this window, and I just move it like that, boom, the whole wall, everything is parametric. And the wall is updated. The hole is no longer over here. If I built this same wall and window in Rhino, I would have to come in regular Rhino and fill in the hole. It would take me hours to do that, what Revit just did there in regular Rhino. So that's why Revit is used to do construction documents for typical buildings, right? And now we can rotate walls. That's a good feature. In 2021, you can have your wall, a regular wall can tip. You know that? It can be on a slope. You don't have to do a mass and build a wall into a mass anymore.
That is something I need.
Yeah, so that's the new feature. I haven't had even a chance to play with it yet because I just got my computer up, like barely have had time to keep up with the class with the new computer. But does that make sense? In Rhino, to do this, you got to learn Grasshopper. So in Rhino, I'd have to make the whole model in Grasshopper, and then when I shift something, that structural member I made, or that that blue purple thing here, to make it move with that, I would have had to build all this in Grasshopper, and then that thing would have moved with that surface change, and it might have been driven by that point. This point back here in Grasshopper would have been the driver, and that little point becomes really important that we were talking about, not the surface so much, because the point will do the driving. Right now, that point's driving that surface. And then in Grasshopper, I gotta realize how important that point would be to drive the surface to make it shift. And that's where if you don't respect geometry in basic Rhino, when you get to Grasshopper, you're not gonna be that good in there, because if you don't realize what drives what, Grasshopper, you gotta build those relationships. It's parameters for building the relationship. And yeah, maybe later this year we could do some basic Grasshopper AIA workshops, right? So you got that. But right now, before you do that workshop, just learn how to make regular geometry, non-parametric in Rhino. And then the next level would be getting into Grasshopper. Okay. Any questions?
Question. Oh yeah, we said it in the same time. I just want to ask you. So it's about the project from Stadio 1. So to develop a conceptual design for the project, you maybe because you're in Stadio 1, the Bluffton, the housing, low income housing. So is this best to use the Rhino for making a conceptual design for 2D and 3D form and developing the shape of the building, just like a first step to just find some interesting shape, or just to work with the geometric things, and then work in Revit, or how you advise? Is that will be okay? If
you could technically work in SketchUp would work if you know SketchUp. If you're just trying to do massing on the site, let's say I would say it depends upon what you're trying to study, right? If I'm trying to study, like right now, it's telling my students for our sites up there in Bluffton, we need to start figuring out how big 8,000 square foot structure would be on the site, right? So maybe you just mass out a mass that would be that square footage. You could do that in Revit. You could do it in SketchUp. You could do it in AutoCAD, 3D. You could do it in Rhino. And then you just need the site plan to scale, right? And plop it down on there. And I mean, if you want to do it by hand, you could do it by hand, right? If you didn't know any of those tools. So for me, I think whatever gets you going the quickest. Now, do you want to spend 8 hours to learn how to do that in Rhino before you even get to that, and you got a deadline Monday? Maybe not. Just go to a tool because then it's more asking the question of what you're trying to study, I think, and how in any software that will let you get there to, you know, to start to see the relationship is the most important thing. So to me, it doesn't matter what software it's in. It's what the question or what you're trying to study, knowing what you're trying to do, and being able to see a visualization of it, right? And I think without that visualization, you don't realize the relationship of how big the site is to the project. Yeah. So use whatever tools can get you there the fastest. Maybe if you got a deadline like Tuesday, right, to start generating stuff, if that makes sense. Yeah. So, okay.
Thank you very much, and
You're
thank you very
welcome.
much for the helpful information that you provided today. It was very helpful.
Okay. And keep me posted, guys, if we want to do some more, like go through Chandler and Jesse there. You guys have an open platform somehow if they have questions or something.
Yeah, whether it's email or Instagram, you know, or even contacting us directly, we're definitely open to that.
And we also have a Slack workspace. So if you haven't gotten the email to join the Slack, just let me know and I can give you the invite. But we have on our Slack channel a specific area for questions as well.
Okay. I'm a beginner in Slack, so I really don't know what it is. You guys might think, and I know it's like a public thing, right? You don't want to be too personal on there.
Yeah, it's a really great way to communicate because you can create certain channels about specific topics. So with an organization like the AIS, we can have one that's all about like social events, one that is about professional events to help make it so you're not just in a giant group chat where things might get lost. And it also seamlessly works between an app on your phone and your desktop computer. So you can put in links and go back and forth and click between them, which is nice.
So it's a little bit like Twitter though, like anybody could become a member?
No, so it's a specific, you have to have an invitation to be able to join a workspace. Okay. And then as like an admin, I can kick people out.
Okay. Yeah, I don't know. Can you do it in Twitter? I guess not. I never used Twitter either. So, okay, well, that's cool. Yeah, I would be interested in that. Stop share. Did we record today? Were you recording?
Yes.
Yes.
Okay. All right.